All right, have your worksheets out? Just problems 5 and 6, we're checking off today. Here we go.
He's like,
Got it. Every sense? Number 5. No solution. Number 6, there are 3 solutions. -7, 6, -4, 2, -10, 2. And it repeats. And that is all the answers. So let me get the towel real fast. And I will be opening it up to questions. There aren't terribly many options, but what you got? Did somebody ask for 6? Yeah. Number 6. All right. Just ignore the calculus. All right, number 6 looks like this. 4x squared plus 56x plus 1y. Whoops. That marker. Plus 142 equals 0. Whoops. And -4x squared. Tell you what, do me a favor, gentlemen. Too much notes. Can you read it out for me, that second equation?
-4x squared.
Plus 21y squared.
Minus 56x.
Uh-huh.
Minus 177y.
Uh-huh.
Plus 110
Equals 0, okay. What method would you use to solve this thing? Nick?
Elimination.
Definitely. What makes that attractive immediately?
Opposite. The first terms are opposite.
Yeah, first terms are going to cancel if you add them. So, add up what we have so far. Anything else happen?
Yeah.
There's one other nice thing that happens, by the way. See it?
I guess the first term is 21y squared.
True.
I guess
That's
the
nice.
x's cancel.
Yeah, the -56 and the positive 56x cancel. So we have 21y squared, okay? These go together. Can you combine them?
Yeah. 160. 168.
Yeah, positive or negative.
Negative.
So -168y, and then these?
252.
Yeah, plus 252 equals 0. Everybody get smart? How would you solve that? By the way, there are people who are absolutely addicted to the quadratic formula. Fine, I love the quadratic formula as much as anybody. However, if you take a quick look at this, if all you do is just plug numbers into the quadratic formula, this is going to hurt. I know this is -b, or it's going to be -b plus or minus the square root of b squared minus 4ac. You're going to have like 5 and 6 digit numbers in this thing if you do the quadratic formula straight away. I would recommend that there is something that's a little easy to do first. Go. Yeah, not quite divide. Well, yeah, according.
Oh, sorry, pull out.
Yeah, there's a GCF of 21. It's not immediately obvious, but y squared minus what? How many times does 21 go to 168? 8 times. 8y plus what? 12? By the way, that's right. If you really, really have a passionate desire for the quadratic formula, if you do this one, you get the exact same solutions as if you had done this. And if you want, you can just divide the 21 off, but I would recommend there's even a faster way. Can I see it? Go. You can unfoil. This thing factors. Into what? Y minus 6, y minus 2. What solutions do you get? Correct. That was actually not bad. However, Sam, take over. Are we done?
No, you have to plug the Y.
In order to get the what?
X.
X's. Plug it in where?
One of the top two.
Yeah, what's the rule? You have to plug it in whichever is. Go.
The lowest degree.
Lowest degree. The lowest degree. In this case, what would that be? Kind of a trick question.
Well, the same.
They're the same. The degree is the highest power. This is degree 2, this is degree 2. So you can actually pick whichever one you like. I don't know, what's your favorite?
Top one.
Top one, I don't blame you. You'll have to resurrect this thing that was temporarily canceled. 4x squared, I'm just gonna recopy it, plus 56x plus 9y plus 142 equals 0. So which one do you wanna try first? Becca?
What are we doing? Plugging it in? Y equals 2.
Okay, try y equals 2. Do it.
4x squared plus 56x
Uh-huh.
plus 9 times 2
Plus 9 times 2,
plus 142.
okay, equals this. What's this?
18.
And what's 142 plus 15?
One's 60.
160. Okay. Take over Katie. Okay, 4x squared plus 56x plus 160 equals 0. How would you solve that?
4.
Yeah, there seems to be a GCF of 4. What's left?
X squared. 12.
Close.
11.
It ends in a 6, if that helps. 4 times something ends in 6.
16.
That would end in a 4. Here, try this. How many times is 4 going to 5?
1.
Once, with a 1 left over. 4 goes into 16. Oh, back up, back up. 4 times. There you go. Plus, take over, Mary. 4 goes into 160.
45.
Correct. Does that factor?
Yes.
Do it.
So it would be 4x plus 10, x plus 4.
Correct. What solutions do you get?
X equals -10 and x equals -4.
Now, I plugged it, well, you plugged in, the y equals 2, and I got 2 different x's to go with it. So what points did that just give you? Go ahead. What is this point? What comma what?
-10, comma 2,
Yep,
and -4, comma 2.
and -4 comma 2. Do you see why both of these have a y equals 2? They both came from y equals 2. Now, let's try y equals x. Let me see, Nate, take over. Gonna plug it in top or bottom? Top, sure. So, read it off for me. If y is equal to 6.
4, 6 squared,
Y equals 6.
x squared,
4x squared.
plus 56x,
Mm-hmm.
plus 9 times 6,
Yes. Plus
plus 142,
142 equals 0. What's 9 times 6?
54,
54. 54 plus 142.
196,
196. 4x squared plus 56x plus 196 equals 0. How would you solve that?
you could factor out a 4. from
Definitely. Pull out a GCF of 4. What's left behind?
X squared
Mhm.
plus 14x
Good.
plus 49.
Yeah. 4 goes into 9 16, so it's 4 times. And then 9. Does that factor? Let me see. Blaze, take over. Unfoil. To what?
X plus 7,
X plus 7,
and X plus 7.
X plus 7. This is a duplicate. By the way, this could also be written as 4 parentheses X plus 7 squared. They'll give you the exact same, so what do you get as solutions?
-7,
And,
-7.
yeah, You do not have to write it twice. So this is kind of like a duplicate. Can anybody tell me, well actually you tell me, what point did that give you? -7, comma 6. This will be a duplicate, you do not have to write it twice. And that is your solution. Does that make sense? Questions? Anybody want to see number 5? Seriously?
I just have a question.
Yeah.
So, for these problems, when you're asking us to solve them, do you want it, for the answer, do you want just what X and Y equal, or do you want it as?
Oh, good question. Yes. They're asking for, if they said to solve each system of equations, you could theoretically write y equals 6, y equals 6, y equals 6 like multiple times. It is easiest and fastest and most informative to write them in points, in point form. If you had written this as x equals -10, y equals 2, x equals -4, y equals 2, I'd be okay with that. You just have to write them again and again and again. Just remember, this y was used twice, not just once. So if you just had y equals 2, x equals -10, x equals -4, and that's it, I would take off about half points. Why? Because that doesn't tell me that this is -10, 2, -4, 2. Does that make sense? An intersection is where the two things solve. A solution is where the two graphs intersect. So if you did this, x equals -10, y equals 2, x equals -4, y equals 2, and over here, x equals -7, y equals 6. If you wrote this and this and this, I'd be okay with that. But if all you wrote was this, y equals 6, y equals 2, x equals -10, x equals -4, and x equals -7, I would take off at least half. Why? Because I don't know which one goes with which. This y equals 2, does not go with the x equals 7, -7. Does that make sense? So here it would be very misleading. So the easiest way to do it is to write them in point form. If you absolutely have an aversion to doing that, then write them like this. Okay, I think this is easiest over here, but this and this and this. Does that make sense? Okay, next. Everybody feeling okay on number 5? Ultimately, when you got number 5, you solve, 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 and then when you try and solve, it doesn't factor, it doesn't complete the square, and when you try the quadratic formula, you're going to be square rooting a negative. That's why it's impossible. It's not impossible because it's hard. It's impossible because it's impossible. Everybody feeling okay? Alrighty, check out your notes, please. Remember, we're studying conics. And there are 4 basic shapes that we deal with. Circles, parabolas, ellipses, hyperbolas. I'm going to give you a variation on one of those today. It's called the diagonal hyperbola. Go ahead and write this down. A diagonal hyperbola, you might remember this from first semester, something called a parent graph. A parent graph is like the most stripped down version of a function, like y equals x squared. No moves, no resizes, no flips. The parent graph of a diagonal hyperbola is this. Y equals 1 over x. We've seen it before. The book called it a reciprocal function, or sometimes a rational function, which is okay. But the graph is kind of interesting. I want to try and graph this thing. Does anybody see a value of x that you would not want to use? Well, 1 would be safe. 1 divided by 1 is 1.
Oh.
But anything below 1, basically?
You could, but there's one value of x I would not want to use.
0?
0. X equals 0 is forbidden. Anybody tell me what would happen on the graph when you tried x equals 0? Yeah,
Make it asymptotic.
an asymptote. What direction asymptote? Horizontal, vertical? If x is forbidden, like what does the line x equals 0 look like?
Is that horizontal? Or vertical, sorry.
Yeah, it's a vertical line. If x is not equal to 0, it's right on top of the y-axis. But there's a vertical asymptote there at x equals 0. So x equals 0 is forbidden, and it creates an explosion or a vertical asymptote. Now, interestingly enough, it causes something else. I'm going to rewrite this just for a second. Y equals 1 over x. Can somebody get x by itself for me? There's a quick way to do it, and there's a slightly longer way to do it. Just out of curiosity, do you remember the quick way? How to get variables out of the basement? There's a super fast way to do it if you remember. You don't have to remember it, but you can do it without. I'll show you in a minute. Do a normal, yeah.
Is it multiply by
That's when you're dividing by a fraction. Close. They're dividing by something. Abby, what did they divide by?
X,
What are you gonna do to cancel it?
multiply
Yep. By what?
X,
Yep. Exactly. What happens here?
they cancel out.
Tell me what's left.
X, y equals 1,
Now get x by itself.
divided by, y,
Yeah, as long as you do it too.
both sides.
What do you get?
X equals 1 over y.
Correct. This formula is identical to this formula as far as math is concerned. If you graph them, they both give you the exact same graph. But the reason I did that, does everybody see how we did that? It's all legal. As long as x is not 0, we can do this, and you promised me it wasn't. Multiply both sides by x, that'll cancel. And then xy equals 1, divide both sides by y, ta-da. Can anybody give me a value of y that doesn't work? Yeah.
horizontal asymptote?
Yeah, y cannot be 0, which means there is a horizontal asymptote at y equals 0. Remember, y equals 0 is a horizontal line at 0. It's right here. So this particular graph has two asymptotes, a vertical one at 0 and a horizontal one at 0. Beyond that, we need to be able to chart it to see what the graph looks like. Just do not plug in 0. I'm going to go like, I'm deliberately going to make this a little weird. Here's what I'm going to do. -3, -2, -1, skip 0. 1, 2, 3. Then do a little break. I'd like you to do this. -1/3, -1/2, -1, 1/3, 1/2, 1. They're not in order exactly, but try it anyway. We're playing with, you could use either one, but I'm going to use this one. So start me off, Courtney, plug in the -3 just into x. What would you get?
Y equals 1 over -3.
Yeah, 1 over -3, or just -1/3. Let's try the next one. Plug in a -2.
-1,
Good. Keep going.
-1,
-1. Plug in 1.
1,
Plug in 2.
2. Oh, 1/2.
1/2. Good. And then
1/3.
1/3. Nice. Now, oh math people. Oh, awesome. Plug in a -1/3. How do you get that?
Just need to divide by a fraction, multiply by this.
Multiply by the reciprocal. That's -3. What's this going to give you? -2. -1. How about this? 3. Keep going. 2. 1. Does everybody see where we got those, by the way? It was just doing the arithmetic off to the side. It's 1 divided by whatever number you plug in. let's graph these. Josh, take over. Graph that first one, where would it go?
Well, it's 2 to the left,
3 to the left,
and then 1/3 down.
1/3 down. Okay. Do the next one.
I'll do 2 to the left,
2 to the left,
and then
1/2 down. Okay, next.
we go 1 to the left, and then 1 down.
And 1 down. Do you see what we're doing? And you can kind of imagine what the graph is going to be doing. This is an asymptote. It's starting to swerve out of the way. But I want some accurate points. Becca, take over. I want you to take, we did -1 already. Try -1/2. -1/2 comma what?
Comma -2.
So where do you graph that?
So we go -1/2.
So which way?
To the left,
Half to the left,
and then 2 down.
2 down. Good. Next one. Over there.
So we go 1/3.
A
to the
third
left,
over,
and then 3 down.
down 3. Do you see what we're doing? This is -3 comma -1/3. This is -1/3 comma -3. If you fill out this graph, it'll look like this. Somebody do the other branch for me. Chili. Stick on the positive sides here. So try this one first here.
Go over 1, down 1.
Actually, over 1,
Oh, up 1.
over 1, up 1. Okay, next.
Over 2, up 1/2.
Over 2, up 1/2. Keep going.
Not over 3, up 1/3.
Up 1/3. How about over 1/3?
Up 3.
Up 3. How about over 2? 1/2, I mean.
Up 2.
Up 2. You just got another branch that looks like this. You just made a diagonal hyperbola. Remember, a hyperbola has 2 branches going opposite directions, and there are asymptotes running in between. It's following the asymptotes. It's getting closer and closer. I'll tell you right now, we do not know where the foci are, but they're somewhere in here. These are the 2 vertices. This is vertex 1, vertex 2. The foci are somewhere on the outside. Where? We can find that out later if we want. This is the only normal way. By the way, I will give you a hint. There's going to be an extra credit question on the test, which is going to involve this. If you jot this down, you're going to have a leg up doing it. Do you see this distance? Think back to your hyperbolas. Remember how you draw them? How you graph them? What do you have to draw first, Mary? Bossy? When you're doing a regular hyperbola, not one of these weird ones, but just a plain old one like going up and down or something, what do you have to draw first? The box, the guide box. So you have to do the horizontal and vertical radii and box. Where's the box? I will say this. For a diagonal hyperbola, the guide box is always a square. For diagonal hyperbolas, for horizontal and vertical ones, it's different. But for diagonal hyperbola, it's always a square. Whatever distance this is, and we could find it if we wanted to, it looks like this. Oops, I went too far. It's supposed to hit right at the axis. Does everybody kind of at least visually see that? So this would be, you'd have to tilt your head a little bit, one way or the other. I'm going to tilt it this way. Tilt your head 45 degrees to the right. Here's your sort of horizontal radius. I'm going to put it in quotes. And here's your sort of vertical radius. And you can find your foci from those. You can find the focal move from that. You will need to find the length here. We'll give you a hint. The Pythagorean theorem can help you with that. That's all I'm going to say because that's an extra credit problem. But there is gonna be an actual assignment for graphing these things. You won't have to analyze them, but you will have to graph them. I do wanna show you one last thing about these diagonal hyperbolas. It's possible to move them, resize them, and flip them. Let me show you. A diagonal hyperbola, I gave you the parent graph, but I didn't give you the general formula. For diagonal hyperbola, let me abbreviate. Looks like this. Remember with circles, I give you a generic one, x minus h parentheses squared plus y minus k parentheses squared equals r squared, blah, blah, blah. Here's what it looks like. Y minus k equals a over x minus h. Please memorize that. That is the formula for diagonal hyperbola. Where h comma k is the center. And a is the height multiplier. And there are two other things. There's a vertical asymptote and a horizontal asymptote. The vertical asymptote is always going to be x equals something. In this case, x equals h. And the horizontal asymptote is y equals something. It's y equals k. That's largely all you're going to have to know, except for one last thing, the pattern. Every parent graph has a pattern. A parabola has a parent graph pattern of over 1, up 1, over 2, up 4, over 3, up 9. If you're doing a radical graph, it's over 1, up 1, over 4, up 2, over 9, up 3. All of the parent graphs have different patterns. The pattern for a diagonal hyperbola is this. Over, up. Here's how it goes. Over, I will say plus or minus 1. Up, plus or minus 1. Over plus or minus 2. Up plus or minus 1/2. Over plus or minus 1/2. Up plus minus 2. Then do plus minus 3 with plus minus 1/3, plus minus 1/3 with plus minus 3, and pretty much blah, 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 blah. Plus or minus n corresponds with plus or minus 1 over n. That's the pattern. So over 1, positive, that means you go up positive. That's the basic parent graph pattern. We're going to graph one of these in just a second. For example, graph the following and list center and the asymptotes. So we're not doing a full analysis, we're just doing a y minus 5 equals 3 parentheses, or not parentheses, over x minus 1. Actually, let me just do 1 over x minus 1. Let's make it easy first. All right, change the 3 to a 1. Sorry. Can somebody direct me to the center? What comma what? Well,
5, 1.
close.
1, 5.
Yes. 1, 5. The x part comes first. H, okay, 1, 5. I would graph that right away. There's your center. And remember, the center is where the two asymptotes cross. I would immediately do this. Everybody look up here. Once you got the center, immediately draw an asymptote across and up down through it. And you'll be about halfway done. You've also got equations now. You've got x equals 1 and y equals 5. Those are the horizontal and vertical asymptotes. Or vertical and horizontal. Can anybody tell me how to graph this thing? What's the pattern that you use? Right, go ahead. Start at the center and go where?
To the right one,
Right one?
up one,
Up one. Good. Go backwards. What if you want left one?
down.
Down one. Watch what I'm about to do. If you want a quick graph, trace the asymptotes. That's really all you have to do. If you want a more accurate graph, you can go over 1/2 and up 2, over 2 and up 1/2, that sort of thing. I'll do that once just to show you. Start at the center. Sometimes put an X at the center. Go over 2, up 1/2. See? Then over 1/2 and up 2. They're always flip-flopped like that. Over 3, up 1/3. Over 1/3, up 3. There's always going to be a mirror image somewhere. Same thing down here. Over 1/2, down 2. Over 2, up 1/2. See how that works? That's how you do these. Let me hand out the worksheets. No problem. I am going to change the directions. The computer has its own pre-generated directions, which I don't like, so I'm going to have you change it a little bit as soon as everybody gets a sheet. No problem. Okay, on the front page, please direct your attention to the instructions. I need to change some things. Grab a pen or pencil or something like that. On the front page, 6D-1 diagonal hyperbolas, that's fine. For each function, identify the points of discontinuity, holes, and horizontal asymptote. Put a line through that whole thing. Don't line through, then sketch the graph, because I do like that. I will just say, the thing you lined out, replace it with find the center and asymptotes. So the total instruction for each function, find the center and asymptotes and sketch the graph. That's all you have to do. Does that make sense? I do want to show you one last thing. I want to do number 2 together. Some of these are not quite in the right, actually hold on. I'm going to do number 4. Number 4 is a little more involved. Number 4 looks like this. To give you this equation, f of x equals negative in front, then 4 over x minus 2 plus 2. Can somebody give me in the proper form? It's not in the proper form yet. Good. First of all, what is f of x?
Y.
It's y. Good. There's one little thing that needs to move.
Minus 2.
Correct. I would subtract the 2 onto the side. Y minus 2 equals, where would I put this minus? Everybody look up here. This is kind of important. The minus they put right in front of the fraction, which I don't like them doing. Yeah. Yeah. Add the opposite. You can put the negative in the bottom, but that's harder and more likely to have mistakes. It also messes up common denominators. So it's negative 4 over x minus 2. Start from here. Where's the center? Well, 2, 2. Yeah, 2 comma 2, and that doesn't much. It's this comma this. What is the horizontal asymptote? Back up. horizontal lines, are they x equals or y equals?
Y,
They're y equals. In this case, y equals what?
y equals 2.
Y equals 2. This is actually kind of a dumb problem because they're both the exact same number. And then what's the vertical asymptote?
X equals 2.
X equals 2. Just be sure you know which one is coming from which. The y should go with the y. The x should go with the x. Okay? So once you graph it, part of this should be easy. 2 to the right, 2 up, put your center, and then immediately run asymptotes through it. There is something a little weird about this though. Over, up. The normal pattern is over plus or minus 1, up plus or minus 1. Over plus or minus 2, up plus or minus a half. Over plus or minus a half, up plus or minus 2. Let's just play with that for a second. What's the height multiplier? Okay. -4. What is that going to do? The height multiplier is -4. Is it normal height? No. Taller or shorter? I understand why you say that. Negative doesn't make it shorter, it just makes it what?
Sorry, it's not the, whatever I said, it's not that.
Okay. What does it affect the over or affect the up?
Oh,
It affects the up. The height multiplier affects the height. So instead of plus minus 1, Nate, take over.
It's gonna be -4.
Kinda sorta. Plus and minus 1 is now going to be what?
Plus or minus
Very close.
-4.
Minus plus. That is a legal sign, believe it or not. I actually looked it up. Do you see what that means? If it's positive 1, it'll be -4. If it's -1, it'll be positive 4. Is that clear? Graph department. If you go 1 to the right, what should happen?
Can you repeat that?
If you go 1 to the right, what should happen next?
Down 4.
Down 4, exactly. Watch this. Put a dot. Josh, take over. What if you went over 1 to the left?
Then you go up 4.
You go up 4. Clear? What if you went over to the right 4? Nick,
Over 1.
Up 1.
up 1. Actually, not up 1,
Yeah,
but
down
down 1. What if you went to the left 4?
Down 1 as well.
Well, left 4 is negative.
Up 1.
Up 1. Do you see what I did? Normally it's to the right 1, up 1. Upside down would be right 1, down 1. But it's 4 times taller than normal. If you have at least 1 or 2, if you have the vertex or at least 2 other points, you should be able to finish the graph. Just make sure the vertex is somewhere in between. Whoops, that went way too far. Make sure you don't hit the asymptote. I'll accept that as an answer. Let me see what we just did. Over 1, down 4. Left 1, up 4. If you went to the right 2, actually somebody else tell me, what would the new jumps be? If you went to the right 2, what should happen? Go.
Down 2.
Multiply this by 4.
2.
It's 2. Excellent. This is minus plus 2. This would be the 8. Does that make sense? Whatever the heights are, multiply them by 4 and flip them. Is everybody clear? Okay. Your assignment is 1 through 8 for tomorrow. Go for it. Let me know if you have any questions. Yeah.
For number 2, what would K be? Is it just 0?
I don't see a K. It's plus what?
0.
It's plus 0. Correct. Number two, it's k at the very end is plus 0. So you can subtract 0 from the other side. So it's basically y minus 0 starting front for number 2. Correct. Same thing for number 3. Feeling okay? All right, so problems 1, well, number 1, it is upside down, but normal height. You should be able to get it from there. Let me know if you have any questions. Otherwise, go to it. All right, people watching at home, God bless your recovery. See you later, Megan.